All right, guys, here is the recording for the continuation of 4.2 notes, okay? Example 2, for each of the following, the interval inclusive A to B is given. Let big capital A is a point, little a, comma, f of A, and let B be the point, B, comma, f of B. Write an equation, A, for the secant line, AB, that means connecting dot A and dot B. B, write a tangent line to F in that interval A to B that is parallel to A to B. So this is really revisiting the mean value theorem, okay? So let's talk about the secant line. What do you need to write a secant line? So part A, secant line. Okay, you will need 2 points. So the first x is this one, and the second x is that one. So the first one is -1, comma, we'll find f of -1 is, let's plug it in, here we go, 1 minus -1 square equals, oh, why did I write the negative in the front? Sorry, it's 1 minus, okay. So this is going to be square root 1 minus -1 squared is 1, so this is going to give me 0. So that's my first point. My second point is going to be 1 comma, let's find that, f of 1 equals, if you see this, would you agree that it's the same thing, right? It's going to be 1 minus 1 squared, which is 0. So that's again 0. So now you have 2 points, but what else do you need? You need 2 points. You also need a slope, okay? Slope is, what's the slope? y2 minus y1 over x2 minus x1. I have 2 points, so I'm just going to use that. So 0 minus 0 all over x2 is 1. X1 is -1, so minus minus -1. But that doesn't really matter because 0 divide anything is 0. So now you have the slope is 0 and the 2 points. And here is the secant line. Y minus y1 equals n times x minus x1. You can pick either point, but I'm going to pick the positive one, okay? So y minus 0 equals slope is 0. X minus 1, but 0 anything is going to be 0. So my secant line is y equals 0. So that is the line. So that's part A. Now part B says find the tangent that's going to be parallel, okay, to that. So let's do it. I need, again, tangent line, I need 1 slope, okay? So need 1 slope. If it's parallel, the slope should be exactly the same as the secant. So slope is 0. I also need a point, okay? Well, but here's the part that's going to be kind of weird. The point, you're going to need to find where this is parallel to. So even though I have the slope of this tangent, I don't know where this is parallel to. So this is where you would need to do the f prime, okay? So f prime of x, let's do that. First, I'm going to, I should write, here, let me erase this. I'm going to rewrite the f of x equation in terms of power, so I can use the exponent rule. So f of x equals the square root of that, so I'm going to rewrite it as 1 minus x squared and then to the power of half. So now I can do f prime of x equals 1/2 times 1 minus x squared to the -1/2, then multiply by the derivative of the inner component, so that's going to be a -2x. I'm going to simplify this out a little bit, so here we go. I'm going to make this piece into a positive exponent by putting in the bottom. So on the top, I will have now -2x over 2 times square root of a 1 minus x squared, because a positive half is square root. The 2's will cancel, so now I have a -x all over square root of 1 minus x squared. Now this is the derivative, okay? The derivative, and I need the slope to be 0. So what I'm really looking for is the x location where the slope is 0. So set it equal to 0 because of this right here, right? Okay, when I take that and I set it equal to 0, so 0 equals negative x all over square root of 1 minus x squared. When I cross multiply, the denominator is going to be gone, so all I have now left is going to be 0 equals negative x, which is x equals to 0. So all I know right now, x is 0. Okay, so x is 0. Now I need the point. So what I do now is I'm going to plug in f of 0 to see where the output is, and that would be my xy point. So when x is 0, 1 minus 0 squared is going to be 0, so square root of 1 is 1. So that's my y. Okay. So now the tangent, I have the slope, okay? I have the point. I'm going to plug it in. Y minus y1 equals m times x minus x1. Parallel lines always have the same slope. Perpendicular lines have opposite and reciprocal. So my point is, let's minimize my point. Y minus 1 equals slope is 0 times x minus 0. This is going to be 0. So y equals 1 is the tangent. Okay. So what does that really mean? It didn't say graph it out, but let me give you a little graph so you can see what's going on. Okay. So here is an x and y coordinate, and this is the part you can copy or you don't have to. It's really up to you. When x is negative 1 on f, okay, so this is x and this is f of x. When x is negative 1, we found that value earlier. It's going to be 0, okay? When x is 1, it was also at 0. When x is 0, it's going to be 1. You know what this is? This is half a circle, okay? So what it's saying is that, hey, when I make the secant line from negative 1 to positive 1, that's my secant line. The secant line is that chord that you are connecting the 2 points. Is there a tangent? Okay, where would the tangent be? Okay, the tangent, remember the mean value theorem said it's going to be at least 1. Okay, one line that's parallel. So here's the line. Would you agree that this line is y equals 1? And we found it right there. What location? The location is when x equals to 0, which is back to here. We found that x right over here. See? So all of that is connected. Okay? Let's try it again. So this one, we have a radical x minus 1. And it is now from 1 to 3. So first, I'm going to see if I can find the secant line. A secant line, I need 2 points, okay? So first, point 1, so f of 1 equals square root of 1 minus 1, that's going to be 0. And another point is 3, so let's plug it in. F of 3 equals square root of 3 minus 1, that's going to be square root of 2, so that's going to be square root of 2. I have 2 points, I can definitely find the slope. Slope is y2 minus y1 all over x2 minus x1. y2 is radical 2 minus 0 over 3 minus 2 minus 1. I'm going on, my brain is kind of going ahead of me. So, all right, so this is rad 2 over 2. So this is my slope. Right? So I now can write y minus y1 equals m times x minus x1. I like to pick points that are easy to work with, so I'm going to pick this one. Okay. So that's my point. I'm going to pick y minus 0 equals slope radical 2 over 2 times x minus 1. So y equals, distribute this. That's going to be rad 2 over 2x minus rad 2 over 2. And guess what? That is my secant line. Yay! Okay. So part B said, go and find the tangent line. Okay, that's parallel to that exact line. Well, tangent line meaning that I'm going to have the same exact slope. Perfect. No need to do the work, okay? But I need to find the point, and this is the part that I don't know. So I need to do the derivative. So f of x is square root of x minus 1. I'm going to rewrite this as a power notation because I'm going to need to do the derivative. Okay, so f prime of x equals 1/2 times x minus 1 to the negative 1/2 times the derivative of the inner component, but that's going to give me 1. So I don't need to worry about that. I will set this equal to the slope because I need to find the location of x where the slope is rad 2 over 2. So the next step I'm going to do is I'm going to write the negative exponent as a positive exponent, or in this case really radical. Okay, so radical x minus 1. Set that equal to rad 2 over 2. Okay, so now I can cross multiply. So this would now be 1 times 2 is 2 equals, now that goes that way, 2 rad 2 times radical x minus 1. Okay, well, these two will cancel. So now I have 1 equals rad 2. Technically, I can put these together, okay, but you don't have to. You don't feel like it. Okay, now I remember I'm still solving for x, so I'm going to divide both sides by rad 2. So now I have 1 over rad 2 equals radical x minus 1. What we're going to do from here is we're going to square both sides. Okay, okay. So if I'm squaring both sides, I now have, what do you think you have? 1 over 2, right? The square root of 2 in the bottom becomes a 2, equal to x minus 1. Now I'm going to add 1 to both sides. So x is now 1, and another half is now 3 over 2. So my x location is 3 over 2. So to finish this point, I just have to plug in f of 3 over 2. Okay, so f was radical x, so this is now 3 over 2 minus 1. Common denominator tells me that I would need to turn the 1 into a 2 over 2, which is now a square root of 1 over 2, which is really a rad 2 over 2. So that's the point. So my y is now rad 2 over 2. I have the slope, I have a point, I can totally finish up writing the tangent equation. Are you ready? So here we go. I'm going to need more space. Y minus y1 equals m times x minus x1. So y1 is radical 2 over 2, because the tangent, you don't have 2 points, so you don't have a lot of choices for your y1 and x1, okay? The slope, oops, I need to fill in the slope, my bad. The slope is rad 2 over 2 as well, okay? X minus 3 over 2. Okay, distribute the rad 2 over 2, so y minus rad 2 over 2 equals, that's going to be rad 2 over 2x minus 3 rad 2 over 4. I'm going to move this rad 2 over 2 to here. Okay, so now I would have y equals rad 2 over 2x. I need to make this into a common denominator of 4, so now this is really 2 rad 2. So if I do that, can you see that I currently have what? Negative 3 rad 2, add 2 rad 2, the denominator 4. So would you agree that I have a negative rad 2 over 4? And that is my final equation. You know what? I would also accept this. So your book has this as an answer. If it's an ugly radical, you can leave it in point so form. I'm okay with that. So that's the end of example 2.